Our questions today about Pascal's principle. Pascal's principle. The first question, Pascal's principle is applied to Pascal's principle states that when a pressure is applied on a liquid enclosed in the container, pressure is transmitted fully to all the parts of the liquid as well as to the walls of the container. And you must know that the liquids are incompressible. So Pascal talk about the liquids only. In hydraulic presses that works according to Pascal's principle, the quantity that being multiplied is the quantity that is being multiplied is the force. What is the function of the hydraulic presses used to amplify the force or used to produce large force using a small one or used for lifting heavy loads? In the ideal hydraulic press, the ratio between the work due to the motion of the big piston to that of the small piston is the work done by the small piston equal to the work done by the big piston. So the ratio between them is equal to 1. In hydraulic press, the ratio between the pressure of the big piston to that of the small piston is 1 to 1. Then the ratio between the force acting on the small piston to the force act on the big piston is force of the small piston is less than the force of the big piston, then the ratio is less than 1. The ratio between the displacement of the small piston to that of the big piston in the hydraulic press. The distance moved by the small piston is more than the distance moved by the large piston, then the ratio is greater than 1. In the cross-section area of the big piston is doubled the small piston. So at equilibrium state of the hydraulic press, the ratio between the volumes of the displaced liquid downward in the small piston cylinder to the displaced liquid upward in the big piston. Here the question is about the volumes. The volume displaced by the small piston equal to the volume displaced by the large piston, so the ratio between them equal 1. The volume equal the volume. In the opposite figure, the ratio of the hydraulic press on the big piston to the pressure on the small piston is 1. The pressure equal to the pressure. And here, the pressure doesn't depend on the cross-section area. The pressure doesn't depend on the cross-section area. So the ratio between the pressures is 1 to 1. If the ratio between the hydraulic press piston radii is 1 over 15, so the ratio between the pressure on the small piston to that on at the big piston when they are balanced in the same horizontal level. Pressure equal pressure. Then the ratio between them is 1. If the ratio between the radii of two pistons of the hydraulic press is 5 over 2, so the mechanical advantage of the press equal. Mechanical advantage equal the radius square divided by the radius of the small piston square. So 5 square divided 2 square equal 25 divided by 4. If the mechanical advantage of the hydraulic press equal 250 and the cross-section area of the small piston is 2.5 cube centimeter square, the radius of the big piston equal to, at the first, mechanical advantage equal area capital divided by area small. Then the big area that is equal pi r square equal 625. So the radius equal 625 divided by pi. Then by taking the square root of the relation, then the radius equal 14.1. A hydraulic press has two pistons. The cross-section area of the big piston equal 10 times that of the small one. If a force of 100 Newton is applied on the small piston, the resultant force at the big piston equal to. Since the area of the big piston equal 10 of the area of the small one, then since an F capital divided by F small equal area capital divided by area small. So instead of area capital, we write here 10 A small. Cancel A small with A small, then the force equal 1000 Newton. A hydraulic press has two pistons whose radii is 10 cm and 100 cm. If 800 Newton of force is applied on the small piston, so the biggest mass can be lifted by the big piston is at the first F capital divided by F small equal R square capital divided by R square small. So F capital equal 80,000 Newton. Since an F capital equal mass times acceleration, so the mass equal 8,000 kilogram. The gravity here equal 10. An ideal hydraulic press has a big piston of radii 0.5. When the mass of 10 kg is placed above the small piston, it balances a mass of 5 times 10 power 3 kg by the big piston in the same horizontal level. So the mechanical advantage equal and the radius of the small one, the small piston is. Since a mechanical advantage equal F capital divided by F small, each of them equal M times G. M capital times G divided M small times G. Cancel G with G, then the mechanical advantage equal 500 without unit. The radius, since in mechanical advantage equal radius square capital divided by radius square small, so the radius small equal by taking the square root, then the radius small equal 0.022. Then the correct answer is letter D. In the opposite figure, show hydraulic press in equilibrium. If the cross-section area of the piston is 10 centimeter square and the force centimeter square. So the density of the hydraulic press is at the first, the pressure acts on the big piston equal to the pressure of the small piston plus rho GH or plus H. Small piston plus rho GH equal to the pressure of the big piston. So F small divided area small, this is the pressure, equal plus rho GH equal F capital divided A capital. By substituting the number and converting 4 centimeter to meter times 10 power negative 2, converting each of the area from centimeter square to meter square times 10 power negative 4 times 10 power negative 4, then this is the answer. Rho equal 800 kilogram per cubic meter. The opposite figure shows a simple diagram of hydraulic brake system of a car. If the cross-section area of the piston which is connected to the brakes pedal equal 8, this is 8 centimeter square, and the cross-section area of each piston at the brake pedal of the wheels is 12 centimeter, 12, 12, 12, 12. If the driver applies the force of 800 Newton on the pedal, the acting force on each piston of the pedal equal. Let's at the first told you that the pressure F small will be equal the pressure F capital, that is equal also to the pressure F capital, the pressure on the pedal, the pressure on the pedal, the big piston. Pressure on the small piston equal the pressure equal to the pressure of big piston equal to the pressure of big piston equal to the pressure of big piston. The pressure at all the pedals are equal. So B small piston equal P big piston. F capital divided F small equal area capital divided area small. Then the force equal 1200. The force here is 1200. The force here is 1200. The force in each of them equal 1200. Hydraulic press shown in the figure is used to raise the mass M through a height 0.5 centimeter. Then the mass M will raise up 0.5 centimeter by performing 500 joule work at the small piston. If the efficiency of the press is 93%, the mass M is at the first. The efficiency equal the work done on the big piston to the work done on the small piston. The efficiency 93%, 93 divided by 100 to convert it from percentage to number, equal the force times displacement divided by the work done. Work equal force times the displacement displaced by the big mass. This mass displacement is 0.5 upward. Then cross multiplication, force equal 93,000. This force equal mg, then the mass equal divided by g equal 9,300, that is equal 9.3 times 10 to the power 3 kilogram. The opposite graph showed the relation between the applied force on the small piston to the applied force on the big piston and the small one, big piston and the small one. So the mechanical advantage for the press is mechanical advantage eta equal F capital over F small equal 3000 divided by 30. 3000 divided by 30, any number. 500 divided by 5 or 1000 divided by 10, that is equal 100. Question 2. If the radius of the small piston is 5 centimeters, so the radius of the big piston is. Since in mechanical advantage equal radius square capital divided radius square small, so the radius equal 50 centimeters. In the opposite figure, the distance which is moved by the big piston upward equal. From the figure, the distance moved by the small piston is 5 centimeter. The force equal 40. The force by the big piston is 200 Newton. Then Y2 equal. Since an F capital divided by F small equal Y1 divided by Y2. Then Y2 equal 1 centimeter. In the opposite figure, the press at the small piston equal. From the graph, the pressure on the small piston equal to the pressure of the big piston plus rho hg. The pressure on the small piston equal to the pressure of the large piston plus rho hg. The pressure on the small piston equal F over A, the pressure equal force divided by area plus rho hg. Substituting the numbers, here the pressure on the big piston equal mass times acceleration. Mass equal 10, well gravitational acceleration equal 10, then F equal 10 times 10, M times G, divided by area 10 centimeter square times 10 power negative 4 to convert it from centimeter square to meter square, plus rho, density of water, height equal 100 centimeter times 10 power negative 2 times the gravity 10. Then the pressure is 1.1 times 10 of power 5 Newton per meter square. Two identical cylinder vessels with their bases at the same level. Each contains a liquid of density rho. The area of either base is A, but one vessel of the liquid is higher H and the other liquid is high H2, where H2 is less than H1. If the two vessels are connected, the work done by the gravity to equalize the level is. Let's see the diagram. This is the two cylinders. One of them is higher than the other by delta H. H1 is more than H2 or H2 is less than H1. To equalize the level of liquid in the two branches, then delta H will decrease downward and increase in the other side. Then the height will divide it by 2. The height will divide by 2. Delta H will decrease and also increase in the other side. So delta H will be divided by 2. So delta H divided by 2. Delta H will decrease and also will increase. To be equalized, divided it with 2. So the volume displaced downward equal to the volume displaced upward. This is the level displaced in each tube equal half H delta H. Delta H here equal H2 H1 minus H2. Delta H equal H1 minus H2. This is the difference between the two heights. Delta H equal half H1 minus H2. Let's start. Since the work done equal force times the displacement or the difference in height, work done equal F times the distance, delta H, work done equal force equal mass times gravity times delta H. Mass equal rho volume times gravity times delta H. Volume equal area times delta H. The volume displaced equal the area times delta H. Delta H times delta H power of 2. Let's make delta H power of 2. Then the work done equal quarter H1 minus H2 square, half square equal quarter, the bracket square, here is the bracket square, rho AG. Then the correct answer is quarter H1 minus H2 square, rho AG.